My name is Rune Bjerkestrand and I'm the founder and managing director of Pickle. In this video I will show you how we make digital preservation future-proof. We in Pickle are concerned about the challenges related to the secure long-term preservation of valuable digital data, documents, images, video films or sound files that are important to preserve for the future. In 2009 we started developing a technology for digital preservation. We have carefully considered how to ensure it will be possible to retrieve the files at any point in the future, when our own technology might no longer be available. It has taken us years of research, but we have actually managed to build a future-proof solution with no technology or vendor lock-in. This has been possible thanks to the unique attributes of high-resolution photosensitive film. Film is a robust offline medium with an expected lifetime of 500 years. And it has been used for decades to preserve documents and images in a visual format. We in Pickle make it possible to preserve digital files on film. I will now show you the principles behind Pickle's preservation system and what we have done to ensure it's future-proof. I will use some different items, like this booklet. I will use a strip of film. I will use a magnifying glass. I will use a light source. And finally, I will use a mobile phone with a camera. This booklet is called The Digital Dilemma and is written by the American Academy of Motion Picture Arts and Science, known for the annual Oscar show. The document describes the motion picture industry's struggles with saving film for the future after the change from analog to digital productions. The document contains 84 color pages. On this film strip, you can see the same digital dilemma document represented in a visual representation on the film. And we can print it with a different number of pages per frame, as you can see here, all the way from 2 pages per frame up all the way to 20 pages per frame. In this frame you can see the same document written in digital format. The frame consists of 8.8 million pixels or data points. By zooming into the picture you can see more details. By decoding the frame you will be able to retrieve the original file with the exact same information as we have here in the printed version. So this one frame contains all the 84 pages in color as the original file. Now, how can you retrieve your data if Pickle is no longer here to do it for you? Actually, you will be able to retrieve your data in the future with only a light source, a magnifying glass, and a digital camera and a computer. You can use any camera or computer of the future, no matter what shape and form they have, as long as it has sufficient resolution and computing power. Since cameras and computers are getting better, we actually believe the retrieval process will become easier in the future. Let me show you the principle. On the leader of the film, we have written a digital table of contents and the source code of the Pickle retrieval software. The source code is written in visual format so that you can read it with your eyes through a magnifying glass. So I put the film on the light source. I use the magnifying glass, put it over the frame with the source code. Make sure I have a sharp image and place it over the magnifying glass, make sure the focus is adjusted and take a picture. The source code is compiled into an executable program on a computer. I then take a picture of the digital frame. So here we have the picture of the digital frame, and when I zoom in this picture you can clearly see the single pixels that represents each data point. I let the program I compiled from the source code read the picture of the digital frame, and you will be able to get back the original file with the 84 color pages. It will be the exact same version as you once wrote to film, with no loss of data integrity or authenticity. By taking advantage of film's unique ability to write both in digital and visual formats, we have turned film into a self-contained digital preservation medium. All information you need to retrieve the data in the future is written in human-readable text directly on the film. For security reasons, we write the source code both at the beginning and at the end of each reel. And similar to other digital technologies, there is no technical limitation to what you can preserve. It could be text, images, sound, or full high-resolution motion picture movies. As examples, here you can see an image of Beethoven and the sheet music of Fürelise. The two digital frames contain a sound clip with Fürelise. You can see an image of Neil Armstrong walking on the moon and the data frame with a video clip from his moon landing. Here you can see a high-resolution image of a world map. If you use a magnifying glass, you can even read the names of the cities. The same map is written as a data file. The same principle for reading back applies to all sorts of data. You take a picture of the frame and you use our open source retrieval software to decode the data. Although we can technically preserve any file on film, we strongly recommend to only use open source preservation file formats, so that you are sure you will be able to open the file in the future. We can write the file format specifications as readable text on the film, similar to what we do with the source code of the retrieval software. I have now demonstrated the principles behind the pickle technology and how we use the unique features of film to offer a self-contained and future-proof way of preserving data. Our clients today do not need to worry about the readback. They simply request the file and then we make it available for them to download. But regardless of what should happen to Pickle and our reading device in the future, you can rest assured that your data will be available for you or future generations.